Okay, so you're learning about quadratics. And in the last chapter, you guys learned about quadratic equations. Do you know what a quadratic equation is? Not the quadratic equation, but like what a quadratic equation is. Okay, so if you have like y equals mx plus b, do you know what that is?
Yeah.
What's that?
It's like slope.
Yeah, this is a line. Like if you graph it, it looks like a line. That's the general form of a linear equation. So if you have like y is equal to 3x plus 2, you graph that thing, you go up to y-intercept, you got some sort of line. Okay, what makes a quadratic equation is because the highest power is 2. Here, the highest power is what? What's the highest power on the x? And the highest power is this invisible 1 right there. Now, if you have y is equal to, let's say, x squared plus 2. What's the highest power on the x?
2.
2. Do you know what the graph looks like of a quadratic equation?
No.
Looks like this. What are those guys called? You know what they're called?
No.
They're called parabolas.
I never graphed it.
Yeah, they're called parabolas. So, like this one right here looks like this.
Because we're on 10.3.
It's okay, same thing, as far as this topic goes. All right, so this thing right here is called a what?
Parabola.
Parabola. And this thing right here is called a what?
Line.
A line. All right, so if I go y equals 3x plus 2, guess what it's going to look like? Y is equal to 3x plus 2. What will it look like?
You want me to graph it?
No, just tell me.
It's going to be 2 on the y.
No, like what shape is it going to be? A circle? A line. There it is. You see it? Okay, if I go over here, y equals 4x to the power of 2. As soon as I hit that 2 up there, what's it going to be? Parabola. Plus 3 or plus 4 moves up. If I put a negative in the front of this thing, it's going to go upside down. See, if I put like parentheses here and go 2, that kind of moves over to the side. If I want to go down a little bit, I can add a negative to that and then move down a little. But no matter what, it's going to be a parabola if the highest power is a 2. I'm going to do a different one. We'll get rid of this line. Y is equal to x squared, x to the power of 2 minus. So, do you know what these points right here are called? Those are called x-intercepts. Why are they called x-intercepts?
It's on the x-intercept.
Well, it's on the x-axis. Right? So, if you have the x-axis right here, it's intercepting right there and right there. Right? So, you can have, how many x-intercepts are on this graph?
8.
1 right there and 1 right there.
60.
No, like 1, 2. There's 2 x-intercepts. Okay. So now, take that. What if I did over here, y is equal to, okay, the orange graph. How many x-intercepts are there?
The orange graph?
Mm-hmm. On the orange parabola, how many x-intercepts?
2.
How many do you think?
No, I'm not supposed to graph.
No, like just look at the graph. How many times does that graph cross the x-axis? Once. So 1 x-intercept. Now I'll go over here. Go y equals.
I'm not supposed to do this though.
I understand, but you need to know what you're doing. Okay. X squared plus 5. How many x-intercepts do you see there?
0.
0. Okay. So one more time, what is this point called right there?
The x-axis.
Well, no, this right here is x-axis. That's the y.
X-intercept.
Yeah, that's the x-intercept. If the graph went like this, what would this point be called?
The y-intercept.
So that's an x-intercept. So is this right here? Okay. And what's this guy called right there?
X-intercept.
Okay. So how many x-intercepts are here?
1.
So you have 1 x-intercept. How many are over here?
2.
So you have 2 x-intercepts. Right over here like this. 1 x-intercept. Okay. And how many x-intercepts are here?
1.
Now how many are here?
Oh, then 0.
0, because the x-axis is right here. So it's not doing that. It's up here, right? Okay, so you have 0 x-intercepts. Okay. Now, there's like 5 different terms for x-intercepts. They all mean the same thing. Okay, so x-intercepts is the same thing as, I'll put them all here. You can have, they could be called the x-intercepts. They could be called the solutions. How many solutions are here?
2.
2. They could also be called the roots. How many roots are here?
2.
2. X-intercepts, solutions. Oh, and they can also be called the zeros. How many zeros are here? 2. Okay. The quadratic formula is based off of the general form of these quadratic equations. All right, so quadratic formula is based off of y equals ax squared plus bx plus c. So this is a quadratic, like a general quadratic equation. You with me? Okay. It could look like this. Y is equal to 3x squared plus 2x plus 5. It could look like this. Y is equal to 3x squared plus 2x. Or it could look like this. Y is equal to 3x squared. These are all quadratic equations. What's the c value for this one?
C. It'd be 5.
Because this one doesn't have a c value.
I thought we were looking at the top.
For this one here.
Then there's nothing.
Nothing, because it's 3x squared plus 0x. You watching? Plus 0. See? What's the c value for this one now?
Which one?
Same one.
0.
Okay. What's the b value for this one?
0.
What's the a value?
1.
What's the a value?
That's 1.
Okay, 3.
3. I thought it was a 1.
Okay. So what is the c value for that one?
3.
The c value.
2. I mean 0.
0. The b value.
2.
The a value. Okay. For this one here, what's the c value? The a value.
2.
The a value.
3.
The b value.
2.
Yeah, so you have to know which is which.
I know which is it.
Okay, so the b is the one that goes with the x with no power. The c is just a number, the constant, like 10 or 5 or 3. And the a is the one associated with the x squared. You with me?
Yeah, I know this.
Okay. So here, when you use the quadratic formula, they're going to set your y value is going to be set to 0. So you're going to have something like this, like 3x squared plus 2x plus 5, and there's a 0 here. Okay, so why is there a 0 here? What was there before?
What?
Y. Now there's a 0. So we're setting y equal to 0. All right, well, what's the y value at this point right here? Right here, at this point right there.
0.
0. And anywhere along where the x-intercept would be, what would the y value be?
0.
So that's why when you see these, like, use the quadratic formula to solve problems, it's always going to look like this. It'll be like 3x squared plus 2x plus 5 equals 0. Because they're setting that y value equal to 0. You with me? Okay, so what does the quadratic formula get you?
Gets you the answer.
What does that mean? What is the answer?
Simplifies it.
It's somewhere on this page. It's on the graph.
The value of the x-intercept.
Yes, it gives you the x-intercept value. Does it give you the x value of the x-intercept, or does it give you the y value of the x-intercept?
X.
How come it doesn't give you the y value?
It's not a y-intercept.
Yes, and also because we know the y value already.
Yeah.
What's the y value of the x-intercept?
0.
0. Okay, so let's say we're going to do this one right here. Actually, let me do an easier one. Let me just make one up. Let's say you have 3 plus or minus square root. Wait, let me write it down. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, you see how the quadratic formula starts off with x? Because it'll get you something like x equals 3, right? And on your graph, you'll notice that like right here, that'll be a 3. So when you get that x equals 3 answer, that's because one of the x-intercepts is 3. But often you'll get two answers. So you'll get like x equals 1 and x equals 3. So this will be the 1 right here, and that'll be the 3, right? If you have something like only x equals 4, and that's it, just one answer. Do you know what that graph will look like?
Yeah.
What would it look like?
Wouldn't it be like a line?
If the x-intercept, like if this answer right here gives you x equals 4.
And it's on the 4.
It's on the 4. Does it go under the 4?
No.
What does it look like?
Doesn't it just go like I don't know.
It'll be exactly on the 4 and then come back up. You see? So how many x-intercepts are here?
1,
How many are here?
2.
So that's why we got two answers here. That's why we got one answer there. But sometimes you'll get no solution. Right? And if I go like this, and I'm over here like that, how many x-intercepts are there?
0.
So you're actually not, you wouldn't get no solution, you'd get 0 actually. You would get 0. So if x equals, no, just kidding, you'd get no solution. Because if you get 0, it would be here, like that. So no solution means no x-intercepts. All right, so now let's pretend like we're actually using the quadratic formula. And let's say you get 3 plus or minus the square root of 36 over 3. All right, how many solutions are you going to get here?
No.
Well, it's going to be an x equal right here.
Oh, then you get 2 and you get negative 2.
Okay, so let's see. So you're going to...
I mean, you get 2 and you get negative 1.
Okay, so you're going to get 3 plus... Well, I can take the square root of 36, right? So what's the square root of 36?
6.
Okay, so we're going to get 3 basically plus or minus 6 over 3. And we'll split that up. So we'll get x equals 3 plus 6 over 3. And x equals 3 minus 6 over 3. And then you said 3 minus 6 is what?
It's negative 3.
And then what do you get?
Negative 1.
Okay, and then over here,
3.
you're going to get 3. Yeah. So how many solutions did we get?
2.
2. So does it look like graph 1 or graph 2 or graph 3?
Graph 2.
Graph
I mean 1, I meant
1, yeah, because we got
I was looking at
that one and that one. All right, well, let's say we get this. Let's do another scenario. And you get x equals 3 plus or minus the square root of 0 over, let's not put a 3 there, we'll put a 4. A 4 over 2. Okay. What are your answers going to be?
that.
Mm-hmm.
It'd be first it would be 2. So x equals 2.
X equals 2, okay.
And then x equals 2.
X equals 2. Do we have to write it down twice?
No.
Nah. How many solutions did we get?
1.
1. Does it look like graph 1, 2, or 3?
1.
So when you get one solution, which is the same thing as one root or 1, 0, it's going to look like this graph right here, like this one.
Yeah.
that's one x-intercept? Is that one x-intercept?
No, that's 2.
That's 2. So which one of these has one x-intercept?
2.
2. So yeah, so this one here, this graph right here would be, if I actually graphed it, it would look like this. Okay. If I graph this one here, where should it intersect? The one above it.
One above it.
Like here, where should my intercepts be?
It should be, for what?
For this problem up here.
Oh, just on the 3 on the x-intercept.
Well, it should be
on the 2.
Oh no, for this problem up here, where's it going to hit the x-axis?
On the 3 and the -1.
So 1, 2, 3, and on the -1, yeah, and then the graph will go like that. So how do you know that when you have one solution, there's something unique about this problem?
That both when you add 0 and subtract 0, it's the same.
Yeah, when you got a 0 in there, you're getting one solution.
Yeah.
All right. Now, let's say you have this. X equals 6 plus or minus the square root of -49 over 2. How many solutions are you going to get there?
Well, can't you not do the square root of a negative?
Yeah, you can't do square root of a negative. So what does that mean?
No solution.
No solution. How many x-intercepts do you get with no solution?
0.
0 x-intercepts. Could it be a real graph?
Yeah.
What would it look like?
It would just be like, I don't know. Oh, it would be a thing.
Like what?
I think it would be a straight line on the...
Well, it would still be a parabola for sure, because these are all quadratic equations. But look over here. We have our no solution. It's this one. What does it look like?
See? Oh, it's just at the up.
Yeah, it could be there or it could be upside down.
Yeah.
But no matter what, it's not touching the what?
The x.
The x-axis. Did your teacher talk about the discriminant?
She didn't even talk about graphing at all.
What did she talk about the discriminant? It's in your book.
No, I don't know what that is.
I saw it. It's right here. Right here. Or if you did your homework, did she assign here 10 through 12 or 38 through 43? Look at those. 10 through 12 or 38 through 40. Did you get assigned these guys?
No.
Are you sure? Okay. All right. Let's see if you can do this math right here. So let's say you have x equals 2 plus or minus the square root of 3 squared minus 4 times 2 times 3. Do I like that number? I do not like that number. 5. We'll put a 6 up here. Put a 7 up there. Over 2 times 4. All right, so we need to simplify that. How do we simplify that?
You would just you do first what's inside there, and you do 49.
Okay, so 2 plus or minus
49 minus 24.
49 minus 4 times 2 is 8 times 3 is 24.
Yeah.
Okay.
And then over 8.
All over 8. Good. All over 8.
And so then 49 minus 5 is 25. So x equals 2 plus or minus
2 plus or minus
the square root of 25.
The square.
Well, can we skip? It's just we'll put 5.
We'll put that for there. Right. We'll do the next step.
Over 8.
Over 8. Okay. Now what?
X equals 2 plus or minus
2 plus or minus
5 over 8.
5 over 8.
All over 8.
Okay.
So then it's 7 over 8.
Do it over here.
Yeah.
So x equals 7 over 8.
And then x equals -3 over 8.
Negative 3 over 8. Cool. How many x-intercepts do we have?
2.
2. Okay, let's try one from your... All right, so this is page 550, number 17. So 5y squared. Do you have a biotest or math quiz coming up?
No.
Okay. All right. Tell me what to do.
For which number?
Well, it's number 17. So I wrote, it says solve by using the quadratic formula.
Here?
Mm-hmm.
Okay. So, did you write it down?
What is it?
It's 5y squared minus 1.
I have it.
Okay. So then, the quadratic form.
Mm-hmm.
Okay, so put x equals...
X equals...
x equals 1. Well, -1. Right, because wouldn't it be... Oh, no, it's negative, so positive 1, so x equals 1.
X equals 1.
Okay, yeah. Plus or minus...
Plus or minus...
the square root of... -1 squared...
-1 squared...
minus 4 times 5
times
times -4
times -4, okay.
and that's all over 2 times 5.
All right. Okay, now what?
And then you put x equals...
1
plus or minus...
the
square root of... -1 times -1, 1.
Uh-huh.
So,
and
1...
And a better way to put it would be in parentheses like that.
1... minus... plus 80
okay,
over 10, all over 10.
all over 10, okay.
X equals
1
plus or minus
square root of 81
all over 10. X equals 1 plus or minus 9 all over 10. Yeah.
Okay.
So then it would be x equals 1.
X equals, how'd you get 1?
Because 10 over 10.
All right, so 1 plus 9 over 10.
Yeah.
Okay, and then x equals
1 minus 9 over 10.
1 minus 9 over 10. And then the bottom one you got x equals 1.
Yeah.
And this one you got
x equals -8 over 10.
Equals...
So it would be -4 over 5.
Good. X equals -4 over 5. All right. Any questions on this?
No, it's easy.
Okay, hold on a second.